Hello YouTube, this is my first video on my module on geometric sequences, and in this video we're going to do two things. We're going to define and identify geometric sequences and also learn a way to write the rule for the nth term of a geometric sequence. And see, the thing here is geometric sequences, they have a very special type of pattern that goes on here. So to define what they are in the first place, we say any geometric sequence, okay, we say the ratio of any term to the previous term is constant, okay? So this ratio is called the common ratio. So if you studied arithmetic sequences before, you look at things called the common difference. Well, we're talking about the common ratio. And we use the letter R to denote this. We say the common ratio, okay? When you think about common ratio, a ratio is like a division problem. So basically what we're saying is the common ratio is what you get is this letter R you get when you take the nth term and you divide out the term right before it. So in essence, you know, we could find this by finding like A4. If n was 4, then this would be A4 minus 1, this would be A3. Or like we could say A100, take the 100th term and divide by the term right before it, which is A99. You know, A99. But essentially we could find a common ratio. So another really quick way of saying what is a geometric sequence, it's any sequence in which the terms are going up by the same multiple each time. So we say like 2, 4, 6, 8, 10 being arithmetic, we'd say something is geometric as 2, 4, 8, 16, 32, okay? Because what this is doing is it's multiplying by the same number each time. And so we say this constant ratio in this case would be equal to 2 for this one I've drawn up here. And the way I've gotten this is I've taken any term like R, you know, R is the term 32 divided by the term right before it. We say 32 over 16 is 2. Or in this instance, we could say take 4 divided by the term right before it. We say R equals 4 over 2. R equals 4 over 2 is 2. We get a common ratio. So identifying geometric sequences is really important. We're going to go ahead and take a look at these 4 that I've got here and say, is it geometric? Well, is there a common ratio? We say, well, 2 divided by 1 is 2. So what we've done here is we've taken this times 2 to get from here to here. We say 6 divided by 2 is actually 3. So I've multiplied this by 3. And actually that's enough to stop right there and say, well, this isn't a geometric sequence because in a geometric sequence, the common ratio is constant. So this would all have to be times 2, times 2, times 2, times 2. And this doesn't happen here, okay? Letter B, we say, well, what could I take times 81 to get 27? Here's where it's important, where we say, in order to come up with a common ratio, you take a number like 27, and you divide by the term right before it. So 27 over 81, this actually reduces to 1/3. And I can actually say, well, we'll point this out here. If we took 1 divided by 3 here, we get 1/3. If I took 3 divided by 9 here, I'd get 1/3. So the pattern here is that we're multiplying by a common ratio of 1/3 every time. So this is a geometric sequence because each time we took it times 1/3 to get to the next one. So we say is geometric. The next one here, are we multiplying or dividing by the same amount every time? Well, we say negative 8 divided by a positive 4 is negative 2. So what we've done here is we've multiplied by a negative 2. If we take a positive 16 divided by a negative 8, you also get negative 2. And if I took a positive or negative 32 divided by a positive 16, I'll get a negative 2. So this one here is geometric. We get to this last one here, and you would think, well, I'm taking it times 3. Times 3 times 3, aren't I? But if we check this across the board, we say 9 divided by 3 is 3. So we get positive 3. Negative 27 divided by a positive 9. If you take that, you get actually a negative 3. And negative 81 divided by a negative 27 is a positive 3. And then a positive 243 divided by a negative 81 is a negative 3. So essentially what you're seeing here is this. We're multiplying by positive 3, but then negative 3. By positive 3, then negative 3. So we say not geometric, this one, okay? So geometric things, just to be really clear on this, they are any sequence of numbers such that the next number and the next number and the next number you're always getting by multiplying by the same amount every time. We call that common multiple a common ratio, and we use the lowercase letter r to denote this. Cool thing about geometric things is that they're such a pattern, a special pattern, that we could actually come up with the rule for the nth term of a geometric sequence. So I'm going to write this a little bit bigger here, but we say an is equal to a1. Now recall a1 is your first term times your common ratio to the n minus 1 power. So what I would like to do is, this is our rule for the nth term of a geometric. I'll actually come write it down here. A1 times r to the n minus 1. What I want to do is a compare and contrast with arithmetic. Remember, with an arithmetic sequence, its rule is an equals a1. So they both start with a1, except for it has a plus n minus 1 times the common difference d. So what I want you to recognize is if you can memorize the arithmetic rule, and you could definitely memorize the geometric one because they both have something in common, you will need for this rule your first term. So you'll need your first term. This is a1. And we also need the common, in this case not a common difference, but a common ratio. And this is r. Okay. So these are the two things we're going to need to write the rule of a geometric thing. But these rules, if you look at them together, we say instead of a common difference, we have a common ratio. And they both have an n-1 next to them. It's just the n-1 up here is in an exponent. So we'll get used to this rule after using it after a while. Let's go ahead and start by finding a rule for the nth term of this sequence. Now, this, believe it or not, is actually a geometric sequence. We're going to need two things to write its rule, and then we're going to use that rule to find a8 is our instructions here. So in order to write the rule, first of all, we know it's the first term times the common ratio to the n-1 power. So in order to write this rule, I'm going to need r. I'm going to need my first term. And the good news is this. We actually already are familiar with our first term. It's -8. The only thing we're missing here is r. So if we need to know r, here's what we'll do. We'll actually find it by taking a term and dividing by the term right before it. So we could say, for instance, r is -12 divided by -8. And this is the same thing as when you reduce it, a positive over a positive, and you get 3 over 2. And this is going to happen with any of the numbers we choose here. -18 over a -12. If we'd have done -18 over a -12, still would have gotten 3 halves. So r is 3 halves. So to write the rule of this, it actually is quite simple. We say the nth term of this, and I'm just getting this from right here, is equal to my first term. So my first term here times r to the n-1. And we'll just put these in. We say r is 3 halves, and my first term here is -8. This seriously is all the rule is. You don't even need to simplify. You can't. So we'll try this again here. We'll say write a rule for the nth term of the sequence here, and we have 5, 2, 0.8, 0.32, and so on and so forth. Okay, so let's start with this. We have a1 is what we need. We need a1 here, and that's 5. We need r. Now r, we'll just pick two numbers here like 2. We say 2 over the number right before it, 2/5. These are our first term and common ratio respectively. So again, writing the rule, we say first term times r to the n-1, where our first term is 5. Just got that from right here. That's right here. And then our common ratio, we're taking this times 2/5 every time, times 2/5, times 2/5. So we'll put that 2/5 in here. We say this is my rule. So that's what a geometric sequence is. It has a common ratio that you multiply each number by to get the next term. And to write the nth term of the rule or the sequence there, you have this fun little rule right here. Cheers.